Okay, so the bug has gone, but your work isn't done yet. The error may have disappeared. The button may be working again. The AI may have said it has fixed the problem. So it seems like the job is done, yeah? But not always. Because fixing the problem, you can see, is only one part of the work. You also need to make sure that the fix has not caused any other problem somewhere else within the system. And this is where a lot of AI assisted building can go wrong. The first test passes. You're like, okay, it's good, it's working now. And then you approve the change. But nobody checks the next user. Nobody checks the older record. Nobody checks the path that is meant to fail. So the original bug disappears, but a new one is quietly introduced. In the first video in this series of loop engineering, we spoke about loop engineering as the control system around AI. The AI can help you move faster, but the human still needs to control the problem, the scope, the evidence, the testing, and the final approval. In the second video, we looked at how to stop fixing the wrong bug. We spoke about finding the first broken contract. In simple terms, that means finding the first place where the system stopped doing what it was meant to be doing, okay? And once you find that point, you then make, a small change just to that layer. But now we need to deal with the next question. How do you know that the change is actually safe? This is where regression testing comes in. Regression testing may sound technical, but the idea is very simple. You fixed one thing, now you check that the fix did not break something else that was already working. And that's it. It's pretty much as simple as that. So you're going to be just checking the system to make sure that everything is still working properly, yeah, as it should be. Because the mistake is thinking that one successful test proves the whole change, and it doesn't. And that's something that's very important, because it only proves that one path worked under those strict conditions. So let's use a simple example. Imagine there is a document inside an app. A user presses the download button, but nothing happens, yeah? So you investigate the path. We see that, or sorry, I should say, you see that the request is being sent correctly. You see that the back end is sending back the correct document, but the screen does not understand the response properly. And that's where the problem is. The problem's in the screen. Yeah? So you make a narrow change in the screen. You do not change the database, you didn't change the permissions, you didn't change the back end, you only, the only change, the part that misunderstood the response. Then you test the download button again. This time it works. So the download button is now working. Okay, so that's a good thing. We've got the immediate problem that we had, we've got that fixed. That's a good thing, yeah? But it's not the end of the testing, especially when it comes to using AI-assisted builds. You need to ask a few more questions, definitely. Like, does it work for a valid user? Or does it work for an older document? What happens when someone without permission tries to download it? What happens if the link has expired? Or even what happens if some of the information is missing? So the answers to those questions tell you whether you have a proper fix or just one successful moment. And I'm not saying that you need to test every possible thing in the whole product after every small change. I'm not saying that. Like that will probably slow down the work too much, yeah? The point though is to test the paths that are close enough to the change that they could realistically be affected. So I use 3 simple checks. The first one is the exact path. This means going back to the original problem and testing it in the exact same way it failed before. So I would use the same type of user. I would use the same action, and I would also use the same information, yeah, from the test when things wasn't working. So what I would be doing is aiming to recreate the conditions as closely as possible. Yeah? And the question is simple. Does the path that failed before now work? And if the answer is no, the fix obviously is not incorrect, is not complete. If the answer is yes, then we move on to the second check. The second check is the nearby path. This means testing the closest normal variation. Maybe it's another valid user. Or maybe it's another type of record, yeah? Maybe it's another browser. Or it could even be an older document. Or maybe maybe it is a different user state that still, sorry, I still lost my train of thought. That still uses the same part of the system. Yeah? Maybe it is a different user state that still uses the same part of the system. So the question here is, does the nearest working path still work after the change? This matters because two different user journeys can share the same screen, function, or piece of logic. So you may have changed one path, but the code you changed may also be used somewhere else. Yeah? And then the third check is the path that should fail. This is sometimes called the negative path. Again, the idea is simple. So obviously, some actions are meant to be blocked. A user without permission should not be allowed through or to download at all. An expired link should not work. Incorrect information should not be accepted as if it were correct. A half finished record should not behave like a completed one. So after the fix, you need to confirm that the system still says no when it's meant to say no, which is also very important. And it's more evident because a change can make the successful path work by accidentally removing a rule that was protecting the system. So you don't want a fix that solves access for the correct user by opening access to everybody, if that makes sense, yeah? So the 3 checks are: test the exact path that failed. Then you're gonna test the nearby valid path. So the closest things to where it was broken. And then you wanna test the path that should still be rejected, making sure some of the security levels that have been put in place have not been compromised, yeah? So what that will do is give you a much stronger evidence. It will give you much stronger evidence than simply pressing the button once and seeing it work, if that makes sense, yeah? And then you don't want to carry on, then down the line you find out something else was broken, and it causes a lot of problems. And when you are using AI to help with the build, your instructions should make this clear. Do not say, fix the download problem. Tell the AI what results you want, but it does not explain how the work should be controlled. Yeah, so a stronger instruction, for instance, would be: the original download path is not working. Do not make any more changes. Test the original failing path. The nearest valid alternatives and the expected rejection path. Report the result of each test separately. Do not say the issue is resolved unless every result matches the expected behavior. Notice what that instruction does. It stops more changes from being made while the testing is being done. Yeah, it tells the AI exactly what path to check. It asks for evidence separately, and it stops the AI from declaring its own success too early by saying, yeah, it's fixed. And we have to remember, the human still needs to choose the right tests. The human still needs to review the results. And the human still needs to decide whether the evidence is strong enough to accept the change. And that is the difference between using AI to produce code and using AI inside a controlled engineering process. The goal is not to slow the goal is not to slow everything down. The goal is to stop false confidence. Because having to repair one more bug later will normally cost more time than checking the nearby paths now when you're doing your initial test to see that whatever was broken is working. So when a fix appears to work, do not stop at the error is gone. No. You need to ask more questions. Like, did the original path pass? Yeah? Did the original path pass? Yeah, that's the first question. We want to make sure that what we saw was broken is that fixed first. Did the nearest valid path still pass? Did the path that should fail still fail safely? And if you're unable to answer those questions, you may have a if you cannot answer those questions, you may have a promising change, but you do not yet have a proven fix. Yeah, so finding the right bug protects you from changing the wrong layer. Testing the nearby paths protects you from turning the right change into the next bug. So remember this, the work is not finished when the symptom disappears. The work is finished when the original path works, the nearby paths remain stable, and the evidence has been reviewed. Build with leverage, but keep control.